Hello everyone, welcome to the class ECE317 Digital Signal Processing. Today we will keep working on the structure of systems. Last time we introduced the structure of systems and we have some basic things. Today we keep working on that. Okay, so this is called ECE317. This is the 11th week, Wednesday's class. Okay, then we consider the structure of systems. We have two types of structures. One is a block diagram, one is a signal flow graph. I use example to explain it. Like we can have structure like this. Z to -1. Here's a -2, for example, right? This is structure. Or we can have like this, Z to -1, -2, and here's a x of n, here's y of n, this is a x of n, this is y of n. Yeah, the same thing. One is the block diagram. Block diagram. This is the signal flow graph. Okay, and for how to get the transfer function, you just list some equations, then try to solve it. For this one, actually this one we can have it very simple. This signal, it is summation of xn and that one, right? So it is x of n minus 2 of y of n, right? It will equal to this signal. What is this signal? This signal by delay it is y, right? This signal by delay is y. So without the delay, so before the delay, this will be y of n plus 1. You get it? Yeah. Y, if here's y n plus 1, then you go to delay, you will have y of n. Y of n equal to, if this is w, there will be w of n minus 1. Right? Then we can have y of n plus 1 plus 2 of y of n equal to x of n. Finally, you can write, usually we keep these, we put this as n. The highest value of n in y should be n. Then this one I replace by n, then next 2 of y here will be n minus 1, and the x will be n minus 1. So we can have equation looks like this. Yeah, we can have equation looks like this. Alright. You can also use this one to give the equation similar. And then we consider some special case of the structure. The structure of FIR field. FIR field, the transfer function can be written in this way. Some like h of 0 plus h of 1 times z to -1 until h of n z to -n. Right, we can also always write it in this way. FIR field as a transfer function looks like this. We can also have the impulse response will be h of 0, h of 1 until h of n. Here's a n equal to 0, right? It's an impulse response. Alright, the structure of these, we can have the structure looks like this. No, this one is going down. This one going up. It's going up and going up until the last one. Yeah, it's like this. Here's the edge of 0, here's the edge of 1, edge of 2, until edge of n. And you will have delay. You need delay, right? Delay you can put in this column or this column. I put here, delay, delay, delay. I can also have the structure looks like this. Okay. Look like this. Here's the edge of 0, edge of 1, edge of n, and I put delay in this side. Okay, so both works, and I can have a name for it. This one is, I say this is a for FIR, and the delays on the left side. All right, this one is also for FIR, but the delay in the right side. The right side. Okay, this is a FIR field. And for another kind of system is a reverse. You just reverse the transfer function. We call that is of all poles field. Now h of z will be 1 over let's say this is 1 minus a1 z to negative 1 minus a2 z to negative 2 until some an z to negative n. This is a you can think it's a transfer function in the reverse way. This one, if you consider this FIR field, the transfer function, you consider this transfer function as a fraction, then this fraction denominator is 1. Here, for all poles field, this fraction is numerator is 1. Okay? Yeah, just kind of a reverse of this one. Then the structure is also similar like this. Similar like this, I put it. Okay, this looks the same. Looks same, but direction is reverse. Here's a feedback. Go back, backward. Okay. Go backward. We call this as a feedback. Feedback. And the coefficients, a1 is here, a2 is here, an is here. Right. And the delay, you need to put delay. You have 2 columns, you can put delay. So you can put delay in the left side, for example here, or like these. We have feedback, one more feedback, and until the last one. And the coefficients a1, a2 until an, and the delay now I put in the right side. Okay, so either structure works. Either structure works, and I can also give name for this. I call this is for all poles field. Delays in the left side. This one is also all poles field. Delays in the right side. Okay. All right. Then today we will consider a mixture. You know, this we have these 2 last time, right? We have these 2 last time. Now we consider mixture. So in general, h of z will be a fraction. It will be a fraction. I say this is it is some constant. Okay, I say this is a use a for the numerator. Okay, or A for denominator. I use B for numerator. B0 plus B1 Z2 negative 1 plus until B some M Z2 negative M is the numerator, and the denominator I still use the same with this. It is 1 minus A1 Z2 negative 1 minus A2 Z2 negative 2 minus until AN Z2 negative N. Alright. Okay. Then the structure, how to give the structure of these? We can write this H of Z equal to H of FIR field times H here's a opposed field, or reverse the order of these two, HP of Z times HF of Z. In the side of mass, in the view of the mass, these two are same. But as a structure, we know when you have two transfer function times together, in the structure there should be a cascade connection, right? So the order is different. Like this one, you put F in the left side. This one you will put P in the left side. Right? Yeah. Where H, this FIR field, it is just a numerator. It's a B0 plus B1 Z2 negative 1 plus until BM Z2 negative M, and for the opposed field, this is 1 over 1 minus A1 Z2 negative 1 minus A2 Z2 negative 2 minus until minus AN Z2 negative N. Right. We write this way. Then the structure okay. Alright. Then we can see the structure. Actually, we have the structure in the textbook. This is one. This is one. We combine two parts together. This part, like in this one is signal flow graph of the direct form 1 structure. Alright, so this way is a direct form 1. In the left side, this is a numerator part, related with numerator part. And you see the structure is the path is go forward, the signals go forward, right? And this side is the backward part. So this is the direct form 1 structure. And this one, okay, this is a direct form. This is also direct form 2 structure. So this way, in here, we have the backward part in the front, in the left side. So the signal from the input side, then go to the backward part first, go to the denominator part first, and then go to the forward part, the numerator part. So this is the direct form 2. And for the delay, right? Each part you can put the delay in the left side or right side. So here, these two sides, outside, they have delays. And this one, because you flip these two, right? Then this 3 go to here, and this 3 go to here. You get this one. So this one, the direct form 2, the delay is in the middle, and the direct form 1, the delay is in the outside. Alright, then we can do the another way. We put the forward part in the left, but we put delay to here. That will be this one. You see. This one. So this is we call this is the transposition with applied transpose. Okay, anyway,
It's a direct form 1 structure, but with a transpose. Actually, it's a transposed direct form 1. Transposed. All right. Yeah. This one, the forward part, the numerator in the left side, and the delays are here. Delays are here, and the backward is this part. The delay is here. And this one, this is a transpose. After transposition, then we have, it's also direct form. Yeah, direct form 2 with the transposition. So the backward part is here, and the forward part is here. All right. Okay, let me write them on the notes. So firstly, we say in the textbook, this is a page 389. Then we have 2. One is a direct form 1. Direct form 1. Direct form 1 structure. This one, I put it here. Okay. I just give one level. Actually, there's a lot of levels depending on the order of the system. All right. And the direction. So this is the direction forward, and this is direction backward. And delays here. Delays here. All right. It's like this way. Like this way. All right. And we say, okay, we have the notation like this, right? So here, we will say, we use our notation here. This is forward, right? Forward, we say this is a forward with the delay in the left side, right? Forward with delay in the left side, right? This one. And this one is backward with delays. This is the opposed part. Right? This is the opposed part. Opposed part and delays in the right side. Right? This one. So this is a PR. Okay. So this is a direct form 1 structure. Look like this. Now here maybe more levels. Right? Depend. And then we have direct form 2. This one also. Direct form 2. Okay, the I for it. Direct form 2 structure. Also can be from the textbook. Yeah, same page. Right? Same page. Okay, I just have it. Alright, and the direction, he has a backward, he has a forward, and the delays in the middle. Okay, like this one. This is a direct form 2. Direct form 2. Here actually we merge it. This is coming from this one. Coming from this one. This is this way. This is this way. Alright. Okay. And the delay So it should be this one. Actually, it should be this one. Right? We have two part. But you see the signal. This signal go to here, going down with a delay, and here coming, go forward. There's nothing change, right? So the signal from here to here is nothing change, and going down with a delay. So the signal go along this path and this path. Actually, they are same thing. They are same signal with same operation, delays, and then go separate to both sides, right? So we can merge these together. We have two delays. Now it's one delay. The signal go to here with a delay, then separate to both sides. So these two are exactly same. The structure different, but as a system they are totally same. Okay, and this one we can also say this is a backward. So this is a opposed part. It's a P, and the delay is in the right side, right? So with R, delay in the right side. And this is a forward and L. Okay, so these two we have two part, right? We have two part. Actually, we use same forward part we use FL, and the backward part, opposed part, we use PR, right? PR and FL. But the location, we switch the location. In direct form 1, the forward, we perform forward firstly, then the opposed part. Right? The signal start from the input side, then to the forward part, then to the backward part, then to the output. And this one, we go to the backward part firstly, and then forward part. Here we have a merge in the middle. Actually, this one we can also do the merge. The same is like this. We can also merge the middle part together. In the wrong direction. Sorry. This way. This is upward. Right. This way. So this is going down with a delay. It's going down with a delay, and like this. You can merge these two paths together. Right, together. Then you get things looks like this. But when you merge these two lines together, you save. Do we save something? Right here we save one delays, two delays, now one delays. If you have two columns, then you can save the delays, save a lot of delays. And here you do summation. Now you need you see here no summation just coming up. Then summation here and summation here. You have two summations here, right? This one is summation. This one another summation. Two summations. Now when you merge them together, summation here you have summation. Then you have another summation. So these two structures, usually you didn't save anything. You do summation. Yeah. So just when you look at it as a graph, it looks simple. You have less paths. Just one path here in the middle, and here you have two paths. But when you do the operation, you actually each point maybe you need to do some operation, right? So these two, the operations almost same. When you have more layers, maybe save a little. Yeah, things like that. So people usually just keep these, do not do the merge, and this one do the merge them together. Okay. Then we have the transpose one. We have the transpose one. Let's see here. Transpose one. Let me put it in my nose. Okay. So this is a I only gave the block. Give one level. Actually, it should be several levels. Depend, right? Okay. So this is a forward, this is a backward, and the delays are here. Delays are here. So this is a transposed direct form. Transposed direct form. Transposed direct form. Direct form. This is a direct form 1. Okay, so this is transposed direct form 1, and we also have transposed direct form 2. Now it's a merged one. The middle part merged, so it looks like this. Right? These two blocks they merge together in the middle part. Yes? And this is a backward, this is a forward, and delays in the middle. Okay, so these are the transposed structures. And we also, let me put the name as ours. So this is forward. This is forward. Forward when the delay in the right side. So this is a forward delay in the right side. And the backward is for the opposed part. This is a backward part, opposed part, and delay is on the L. And this one, we have, this is forward. Right? This is forward. So this is a forward and delay in the right side. And this is the backward, opposed part, and the delay in the left side. Okay, so we have these four. The direct form. All of them are direct form. They are the original direct form. These two we call them transposed direct form. Transposed direct form. And similar, this is a combined in the middle pass, because in the middle both are delays, so we merge these two together. Similar, but it's coming from this one. Delay in the middle, and he is coming up. This is a backward, this is forward. Like this way, like this way. So the middle part we merge them together. And this one you can also merge it. You can merge the middle pass. Right? These two middle pass is going down, right? Going down. So this is going down, then forward, this is backward, and delays here, delays here. Yeah. So you can also, this structure you can also write in this way. But it didn't save anything, you know. Here you have separate. Oh, this one might be save something, right? Do you save something? No, nothing. This is no summation. This is just a separate, right? Separate two paths. And summation is here. Summation. These two are summation. These two are in the middle. No summation. Just a separate. Yeah, separate. Okay. So this is a transposed direct form 2. Okay. Then why we call them transposed? We compare with the first two without transposed one. This is a direct form 1 with transposed. This is direct 1. You compare these two. This is a P in the back, now P in the front. This is F in the front. This is F in the back, right? Yeah, we think left side is the first in the front, right? When you perform, the signal go to the left side firstly, right? and second part, then follow to the forward. So this part, right? So this is, we call this is the first, this is second, this is first, second. Now the P in the first, this is P in the second, this is F in the second, this is the F in the first, right? So you reverse the F and the P, and also you reverse the left, the location of Z, right? This is a FL, now it's FR. This is PR, this is PL, right? Yeah. And you can also think, you look at these two, you see this is coming up, right? Coming up as a graph, this is coming down. So here's up, here's down, here's down, here's up. They're just kind of transpose, you see, up and down, down and up. And here's a forward, here's a backward, here's a forward, here's a backward. So this part, you just change the direction. You change the direction, you can get this graph. And this is just the direction, the number. You need a number. You need to change the. You can also need to move the number, not just change the arrow, not just change the direction. The number are also different, right? PL part, the number is coming from the denominator. Here's it from denominator, right? And this is the FL is coming, number is coming from numerator, Okay, so this is a transpose direct one, right? Similar for the direct type 2, you can do a transpose to get direct type, transpose direct type 2. You see, this is going down, now it's coming up, right? Here's coming up, these two are coming up, now here these two directions are going down. And this is a forward, now here's a backward. This is a backward, here's a forward. So as a structure, you just change this part, change all the directions you get. Then you need to put the numbers in the right location. Denominator numbers go to the backward part, go to the feedback part. Numerator numbers, coefficients in the numerator go to the forward part. Right? Yeah. So this is transpose direct form 2. Right. Okay. We have these two. Right. Two part. Actually, each part we have two different way. So totally we have 4 structures. Any more? Actually, we start from here. We can only have these 4, right? For the numerator part, we have 2 choices. For denominator part, we have 2 choices. So when you combine them together, then totally 4 choices, right? Totally 4 choices. 2 by 2, so 4 choices. We have these 4 different cases. Now maybe you can think like this. So like here we have delays in this delay in the left and this delay in the right, right? We have this. Can you think like you put this delay in the middle, in the right side, and keep this also in the right side? People usually do not do that, because when you put it in this way, they are symmetrically, and you can merge. You can merge them. You can leave it here, but if you like, you can merge them together. So people use this way, and this is also because the Z in the middle, right? So you can merge them together. Actually, here, if you only consider the structure as a calculation in the computer, the merge is not necessary. But you can imagine if you build some circuit in a, build a system by some circuit or some part, then you can save one. Like here's wires, right? You can save one wires. This is also a good feature, right? So people can merge them together. People like this way. People like it in this way. So keep these in the same style. So you can't merge them together, right? So people use this one. All right. Yes. Okay. Now let's look at an example. We want to find the structure of systems, you say h of z. This is transfer function, is a fraction. The numerator is 1 plus 3 z to negative 1 plus 2 z to negative 2, and denominator, again 4 numbers, is 1 minus 11 over 6 z to negative 1 plus z to negative 2 plus minus 1 6 z to negative 3. 1 and 2 and 1, yeah. Okay, and you this one, h of z. This is h of z. Of course, we just consider this is a causal one. It's causal system. Causal system. So by this way, that means our C, there will be z larger than some number. Yeah, that k will be one of the poles, the largest pole, right? Our C will be this way. So this is a certain one, is a fixed one, and we can have the structure. Now we have 4 different way of the structure, right? We just follow these. Okay. Here we have the structures. The first one is direct form 1 structure. So it will be looks like this, right? So we have, okay, the first pass, that will be same. Just look like this. Okay? Just look like this. Yeah, if you want to use this one, is also fine. Either one works. Okay, let me use this one in the middle one. If this one, then we do not need this. So this side is x, this side is y, and in the middle it will be, we have numerator, we have 2 level. Yeah, we have 2 delays, and denominator we have 3 delays. So totally, actually, we need 3 delays. 3 delays. Coming up. Actually, delay in the left and the right side. And this one is forward. So this is a numerator. Forward is a numerator. Numerator we only need 2 level. So delay here, 2 delays, going down. Then the coefficient, they are 1, 3, 2. So it's 1, then nothing. You don't need to put 1 here. Then 3, then 2. Okay. And then the forward. This is forward. Then the backward part. We need a 3 level. Right? Backward. And here's a delay. We need 3 delays. And the coefficient. Okay. We need these 3 coefficients. Here you have to pay attention. When you want to find the structure of a transfer function, you have to check this number. If this is not 1, you need to make some change. Make this to be 1. Remember? If you look at it, this one, all these structures, we have a requirement. We need the denominator part. Here should be 1. This coefficient should be 1. Then you can have this one or this one. If this is not 1, you need to make change. Make this to be 1. So here, if this is not 1, you need to times or divided some numbers on both numerator and denominator. Make this to be 1. Okay. So this one, then these numbers will be 8. Those 8. So first one, this is 11 over 6. Now here should be minus that 8. Right? So this is 11, 6. Then negative. Here's a minus, negative. Now here should be positive. And here's a plus. Here should be minus. And here's a minus. Here should be plus. 1, 6. Okay. So this is the direct form 1. Right? And we have 4. We have 4. Okay. Here I just put 2 already. Similar thing. Then I have the, for example, I gave the transpose direct 2, the transpose direct form 2. Is it this one? Is it this one? So the whole structure, we still, the first pass, I still need this, right? So we need this one. And then here I need a 3. Now the backward part is here. So backward part is here. Oh, similar with this. Similar with this. Backward is here. Backward is here. Right, backward is here. And forward, we need 2 forward. Right. After you determine this backward, then this pass, the direction of this pass must be going down, right? If you're going up, this signal cannot flow along it, right? Cannot flow along it, cannot run along it. So you have to, when you determine this forward or backward, then this pass, the direction of this pass, you can choose only one choice. Okay, so delay is in the middle, delay in the middle, delay in the middle, delay in the middle. You have 3 delays. And the forward part, okay, let me go back here. Forward part is coming from the numerator. You just put coefficients 1, 3, 2. 1, 3, 2. You can put 1 or do not put 1, doesn't matter. If, for example, if here is a 3, then you have to put 3 here. You have to put 3 here. Now it's 1, just 1. And this side, the denominator, the coefficient similar, 11/6. You need to change the sign. This minus, here should be positive. Then plus 1 here, then here's minus 1. And here's minus 1/6, here's a plus 1/6. Alright. Okay, this side is X, this side is Y. Okay, this is the second structure. As I put it, as any two structure. You can choose these 2. You can also choose, we have 4. You can choose any 4, any 2. You know how to do it, right? You just follow these. If you are familiar enough, you can remember that. If you are not so familiar, you can go to the notes or you check the textbook. Then you know what is the structure of the direct type, direct form or transpose direct form. Now we can still consider this example, but with more choice. Here I just write a numerator and a denominator. They are polynomials, but we can write this as a multiplication of some factors. Then the structure can be different. We can have more choice. Here let me write in this way. Now h of z equal to, I separate them as factors. So the first one, the numerator, numerator will be easy to separate as factors. There will be 1 plus z to negative 1 times 1 plus 2 z to negative 1. Right? Just like this. Okay, no problem, right? Yeah. And the denominator, there will be a little bit hard. You can use MATLAB to work on this. MATLAB, you can see. Here I have a coefficient. I put the coefficient here in A. There will be 1, then negative 11/6. It's not dot, sorry. Then it's a negative 11/6. Then, I forgot. 1 and a negative 1/6. 1 and the negative 1/6. Okay, these are the coefficients. Then you check roots of A. Roots of A. Actually, roots of a polynomial, and A contain all the coefficients of that polynomial. So when you run roots of A, related with the roots of a polynomial. Now I have 1/2 and actually it should be 1/3. Should be 1/3. Okay. So it will be, copy. It is 1. So this is 1 minus z2 negative 1. Right? The roots is 1. And second is half. It's 1 minus 1 half z2 negative 1. And third one is 1/3 z2 negative 1. It will be this. Separate them in this way. Then we can give the structure with more choice. Okay, that'll be next example.
I have h of z equal to I use 1 minus 3z to negative 1 plus 2z to negative 2, and the denominator I use 1 minus 1 half z to negative 1 times 1 minus 1/3 z to negative 1, and 1 minus just z to negative 1. Okay, we have h of z like this. Then we can have different way to give the structure. This one I can write in this way. This is 1 minus 2 z to negative 1 times 1 minus, they cancel. So I use plus. I use plus here, right? The plus z to negative 1. Yeah, if it is minus, they will be cancelled. I use plus. Okay. And denominator is 1 minus 1 half z to negative 1, and 1 minus 1/3 z to negative 1, and 1 minus z to negative 1. Okay, so you just look at this one. We can have different way to give the structure. The first one, of course, you can give the structure overall. Use either of those 4 different type, direct form 1, transpose direct form 1, or direct form 2, or transpose direct form 2. So we have 4 different ways, right? So we can give the structure use either one. So structure, optional, structure. We have the transpose, just direct form 1 or 2, or transpose direct form 1 or 2, right? So we have these 4 different structures. Let's say this is the set A, and the B, I write h of z equal to, it's a multiplication of these, right? You have 1, 2, 3, 4, 5. You have 5 pieces, and you can write it as a multiplication of, where there's a lot of choice. For example, this one is, I write it as 1 plus 2 z to negative 1 in the numerator, and denominator I times these two together. I have 1 minus 5 over 6 z to negative 1 plus 1 over 6 z to negative 2, and the times 1 plus z to negative 1 and 1 minus z to negative 1. I can write it in this way. Then each one you can have a structure, right? Each one you have a structure. And then the whole thing is this structure here and this structure here. So you have 2 choice. Not 2 choice. You have a choice like this. And they still have different way, because from here to here you can have these 4, right? You have 4 different choice. This part you can have 4 different structure here. And this one you also have, you can use these 4 different structure here. Right? Or like h of z equal to, you just like write it like this: 1 plus 2z to negative 1 times 1 plus z to negative 1, then over the each part. Right? You just write in this way. Then you have structure. Each part you have the structure. You have this one go to here, 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 right? This is a for F. You can use both. You have two both. Like I use FL. I put the delay in the left side. This is FIR. I put the delay in the right side. This one is oppose, right? Oppose, and I can put the delay like in the left side. This one I use oppose. I put the delay in the like right side. Here's a I still the oppose filter. I put the delay in the left side. Yeah, you can have different choice. Then this also gives you structure. Right? Okay. So I say this. Yeah, you can have different way. So this B, I call them as a cascade forms. All of them, they are cascade forms because you have several parts and they are connected in cascade way. And how many cascade forms do you have? Oh, there's a lot, you see. Because here I merge these three together and these two, I get this one. I can also use these three together. I use these three together and these two in the front, and I have another one. And I can use the first two, these two as one part, these two as one part, and this one as a single part. Then I have three pieces cascade connected. And even like this. And even this one, these five things, I can put them in different order, right? In different order. Yeah, so you have a lot of choice. You can give the structure of the same system. Right? This is a cascade form. You can also have the parallel form. See, the parallel form. Parallel form. Parallel forms. This h of z, I can write it as, okay, you see this one, right? This is h of z. I do partial fraction of it. So I can have a over 1 minus half z to negative 1 plus b over 1 minus 1/3 z to negative 1 and plus c 1 minus z to negative 1. Then I have three part. Then the structure can be 1 part, 2 part, 3 part. Now here's the summations. So the structure looks like this. This is a parallel form. This is this one go to here, and this one go to here, and this one, okay, go to here. All right. Yeah. And each part, you also have different choice. Here I do not choose do not calculate what is ABC. I just use these as an example. A over 1 minus 1/2 z to negative 1. Actually, you know this one. You have a numerator, you have denominator. Numerator, it is not a 1. The numerator is not 1. So you have structure. You also have the structure like this. I use, for example, I use a direct form 2. Direct form 2, then the feedback will be in the first, right? We have feedback. Now I need one feedback, 1/2. And then numerator will be go forward, but now no z, right? No z here, no delay. I don't need any delay here. I just go here. So here's a. You need to find a before you do this, actually. All right, I explained it. You need to put a here, and Yeah, this is direct form 2. Direct form 2. If you use the direct form 1, there will be here's this one is a form 1, then forward the feedback will be here. Feedback will be here. This is 1/2 feedback, and this is a numerator part is A here. Right? Delay and delay. Oh, yeah, I forgot delay. Sorry, delay will be in the middle, and this delay will be in the side. Right? So you have this one, and you can also have transposed direct form. This should be different. You're interested, you can give them. You can see all of these, they are different. Okay, so each part you can use either one. But this is a parallel form. And here I do the partial fraction separated as 2 pieces. You can also like this, or h of z equal to you can use a plus b z to -1. Here's a for example, I times these two together. That is 1 minus 5 over 6 z to -1 plus 1/6 z to -2 and plus c over 1 minus z to -1. I can also separate the system like this way. Try to find A, B, C, and then you can have a structure similar like this, parallel way, but you only have two part. All right. You only have 2 part, and each part will be not this. This one, the C term will be similar like this kind of thing. But this one, numerator I have one delay, and the denominator I need 2 delays. So you need more. Okay, you need more. Okay. All right. That's all for today. See you next time. Bye bye.